Welcome to the VFD lesson. This lesson we will talk about the VFD structure. The definition of the VFD. VFD is an electrical equipment for controlling AC motor speed by changing motor power supply. Actually changing the voltage and the frequency of the power supply. So we have different names for VFD, which is variable frequency drive, and the VSD, variable speed drive. VVF means variable voltage, variable frequency, or someone called the inverter. Actually, in the VFD, we have the converter and the inverter, but the most important part is the inverter. So sometimes people use inverter for VFD. So a typical VFD is we call the AC-DC AC type. In old days, we also have an old VFD we call the AC to AC, which is also called a cycloconverter. This is used very limited in a certain application, like in the steel plant, in the roller with very low speed. And I would say majority of the VFD is AC, DC, and AC. We call it indirect conversion type. So like here is the line voltage, and we have a rectifier convert the AC to a DC. Then we have an inverter change DC back to AC. So rectifier, inverter, and the DC link here. So DC link, we have two types components. One is capacitor, the other inductor. So we have two types of inverter. One the VSI, voltage source inverter, and the CSI, current source inverter. So VSI, the capacitor is used on the DC part, DC side. So actually, because we use capacitor on the DC, the voltage on the DC will be almost constant because of the capacitor. So the inverter looks like a voltage source, so we call the VSI. So this type of inverter, the DC, we use reactor or inductor on DC side. So the current on the inductor will be almost constant normally. So we call it like a current source. So we call it CSI, current source inverter. So CSI is relatively older technology, and very few company manufacture CSI. They are normally used in the very large horsepower, like big VFD for the starter for the big blower on the steel plant, and also driving the big pump. So normally for the CSI, here is inductor for the DC side, and the converter side normally SCR or thyristor is used to convert AC to DC. And on the inverter side, also SCR is normally used. And the load is typically 6 motor with the electrical exciter. As we can see, this is the voltage on the low side, and this is the current on the low side, and this is torque on the motor torque. So the advantage of the CSI current source inverter is the inverter can do the full project, or we call the regeneration, convert the in a lot of applications, like for example, when you stop a load with the big inertia quickly, or when we use in the crane or elevator, there is a situation, the mechanical energy on the motor can convert to the electrical energy. And if the driver can do the regeneration, then the energy can be regenerated back to the grid. Otherwise, the energy back to the DC side will pump up the DC voltage, or the DC current will be higher, and the driver will chip. So CSI, it's very easy to have the full quadratic function because the current on the inductor will always be like this. And in the motor condition, the output voltage of the converter is like this, plus, minus. And in the regeneration mode, the check angle of the trigger signal of the CI will be, the phase angle will be moved back, and then the SCI will run in the inverter mode. That means the output voltage of the DC will be changed like this. So that means the converter will absorb the energy from the DC and feed back to the AC grid. Disadvantage of the CSI. On the line side, the current is similar with the low side. So it's like a square current, 120 degree, 6 degree, 120 degree. So a lot of harmonic, especially 5, 7, 11, and 13 odd harmonic on the line side. And also the input power quality is very low, especially at low light load condition. And on the opposite side, the waveform is also not good. So this current will be will produce an extra heating on the motor. And the torque pulsation will generate like a resonance problem on the mechanical equipment. So this is the topology for the VSI. We can see on the DC part, we use a capacitor. And here is a rectifier, convert the AC of a grid to the DC. And then here is the inverter. We use a power electronic switch here, typically IGBT. A 3-phase 4 bridge, convert the DC back to AC. And the AC voltage and frequency can be changed, and change the speed of the motor. So the DC voltage is almost fixed, which is decided by the AC voltage. And on the inverter side, we use PWM technology. So normally we use a reference and a carrier wave to do the modulation. Then you get the pulse. So by changing the duty cycle of the pulse, we can change the frequency and the amplitude of the output voltage at the same time. So different from the CSI. CSI, the frequency is decided by the inverter, and the magnitude or amplitude of the output current is decided by the rectifier. But on the VSI inverter, both the amplitude and the frequency of the output is controlled by the inverter side, by the PWM technology. So the advantage of this one is very simple, very simple rectifier, and also a mature technology on the inverter side. And the output waveform is very good, especially the current waveform. When the IGBT switching frequency or carrier wave frequency is higher, the current is very close to the sinusoid with a very low harmonic on the output side, especially on current. Disadvantage of the VSI is standard VSI is a 2-quadrant drive. That means this inverter cannot do the regeneration. For example, when there is the energy converted from mechanical to electrical energy, and then the energy will charge the DC voltage. We could pump up the DC voltage, and if the voltage go to a certain level, the driver will trip by over voltage, because the diode is one directional component. They cannot, the current cannot go backward through the diode. If we wanted to do the regeneration on this VS drive, you have two options. One is you put a DC chop on the DC side to to absorb the and it convert the energy to the heat on the resistor, on the chopping resistor. The other one is to change the diode rectifier to the IGBT rectifier. Similar with the output, a three-phase IGBT bridge, and use PWM technology. This IGBT bridge can do the regeneration, can convert the DC energy back to the AC grid. So this is for today's lesson. You may scan the code to get more information. Thank you.